When we find the surface area of a cone, just like when we find the surface area of a pyramid, we have to be able to distinguish between our H and our L, our height and our slant height. The height is the segment that connects the vertex with the base, making a right angle. Sometimes it hits the dead center of that circular base if it is a right cone, but it doesn't have to. Like, it could be over here someplace, which would mean that the vertex is over here and it would be slanted. That's called an oblique cone. We have a right cone in this particular example. We also have our slant height, which is the length of this lateral edge right here. Back on a pyramid, that slant height was the same thing as the height of one of those triangular faces. But there's no triangles associated with a cone. Instead, let's say that we take ourselves a scalpel and we surgically cut along this slant height here, and then we also cut along this circular base here, and we lay flat that lateral surface. It makes this Pac-Man shape over here. Hey, what's the geometric name for this shape? It's a part of a whole entire circle, and we call that thing a sector. So we often think of just a pie slice as a sector, but after you eat your pie slice, the pie that's left over is also a sector. All right, so let's look at some of the labels on here. So obviously we have our radius of our base, that those two things match up. And then just like with the pyramid, this edge that's right here, it has to wrap around the circular base. So it should be the same thing as the circumference of that circular base, and the circumference formula is 2 pi r. All right, so that's what that length is supposed to be. And then finally, when we, whoa, where are you going? When we sliced with our scalpel along this slant height right here and then laid bare or laid flat that lateral surface, the radius of that sector is the slant height. Okay, so now I'm going to relate this back to a pyramid. Before I do, though, well, hopefully you realize that both the cylinder and the prism formula were basically the same thing, that you could find the perimeter of the base and multiply it times the height in order to find the lateral surface area. Same thing is going to be true for pyramids and cones. So we're going to start with a pyramid here. So the lateral surface area of a pyramid was 1/2 of the perimeter of the base times the slant height. So by analogy, instead of having a P for our perimeter, we're going to have a C for the circumference. And now we have a formula for the circumference. I'm going to take my C out and replace it with 2 times pi times r. So here's what it looks like. And then, of course, I can take half of that 2. It's all multiplication, so I'll just take half of that 2. And then here is my lateral surface area formula. It's very, very easy to remember. It's pi rl. That's it. It's just pi rl. So here, surface area of a cone, we've got the lateral surface area, as we just showed, was pi rl. It's essentially 1/2 the perimeter of the base times the slant height, 1/2 of the circumference times the slant height. R is the radius of our base, and L, of course, is our slant height of our cone. Okay, and then what would I have to do in order to find the total surface area? I would have to, of course, just add in the circular base, and that circular base should just be a pi r squared. All right, before we move on, remember, just like with the pyramid, I may have to relate both the radius length and the slant height here, and I can do that pretty easily. You can see that it makes a right triangle, and since it makes a right triangle, we would just be using the Pythagorean theorem to relate the h, the r, and the l.